Welcome to This Explainer, where we are going to completely unpack the precise, non-negotiable requirements for finding the inverse of a 1-1 function in Cambridge Additional Mathematics. We are focusing squarely on syllabus 0606 today, and we're going to break down exactly what the examiners are desperately looking for when they sit down to grade your papers. I want you to think about this entire process like a master jazz musician. A truly great jazz musician can sit on stage and effortlessly improvise, bending the rules, playing notes that shouldn't mathematically work together, and creating pure magic. But here is the secret. They can only break those rules creatively because they have spent years rigorously memorizing the underlying structure. They know every single scale, every chord progression, and every fundamental rule of music theory. They know the structure so intimately that they can maneuver within it flawlessly. Cambridge Additional Mathematics is exactly the same. You have to know the rigid structural rules of the game before you can fluidly solve complex, unseen problems under immense time pressure. Let me set the scene for you by throwing you into a real challenge from a past 0606 paper. I want you to picture two very typical students taking this exam. Let's call them Alex and Sam. Now, Alex is the kind of student who works incredibly hard but completely overloads every single answer with raw mathematical facts. He provides absolutely zero structured analysis. He completely ignores the actual command word in the prompt. If the question says show that, Alex just calculates. If it says hence, Alex starts from scratch. He throws everything he has ever learned at the wall, just praying that something sticks and the examiner gives him a mark out of pity. Then, on the other end of the spectrum, we have Sam. Sam is incredibly smart and incredibly fast, but Sam always rushes. Sam does the heavy lifting of the algebra in their head, scribbles down a final numerical answer, but completely misses the rigid command word requirements and the strict notation rules. If you were to look at Alex and Sam's exam papers right now, you would see an absolute sea of red pen marks. And it's tragic, really. Why? Because they both actually know the math, they know the numbers, but they don't know the examiner's playbook. They don't know the rules of the game. So today, we are going to fix that. We are going to transform those red marks into green check marks.
To achieve that transformation, we are going to follow a strategic playbook today. We'll map out the core mathematical principles, establish a procedural framework, look closely at executing with precision, and finally cover examiner insights and pitfalls.
Let's dive right into Section 1, Core Mathematical Principles. The 0606 syllabus is explicitly clear that top-performing candidates move well beyond rote memorization. They build connected, conceptual understanding that transfers seamlessly to unfamiliar contexts.
The entire theoretical architecture of this topic rests on absolutely precise definitions. Distinguishing properly between f of x and f inverse of x is your absolute baseline. It sounds simple, right? But you wouldn't believe how many students lose marks here. If you do all the hard algebraic manipulation to swap your variables and solve for y, but you write your final answer as simply y equals when the question specifically gave you f of x at the start, you are literally throwing away incredibly easy marks. You are doing the heavy lifting and dropping the barbell right before you lock it out. This is exactly why we need to introduce a structural framework that is an absolute game changer for writing complex math answers. It's called the Peel framework: point, evidence, explanation, link. Top students use this subconsciously, but we are going to use it intentionally. The point is where you state the mathematical principle you're about to use. The evidence is your meticulous line-by-line algebra where your method marks live. The explanation defines why you took a certain step, for example, explicitly stating a domain restriction so you don't divide by 0 or take the square root of a negative number. And finally, the link. The link ties your entire answer perfectly back to the exact notation demanded by the command word. Let's look back at our speed demon student Sam. Sam rushed to calculation, successfully found the correct algebraic expression for the inverse, but just left the final line reading y equals 3x minus 2. The link part of our Peel framework forces you to stop, look back at the prompt, and explicitly state f inverse of x equals 3x minus 2. It's about speaking the examiner's language perfectly. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
That brings us to a brilliant insight pulled directly from principal examiners themselves. They note that candidates who reference cross-topic connections achieve significantly higher marks. This illustrates exactly why showcasing causal relationships and integrating your knowledge with other syllabus areas is absolutely essential for locking in top marks. In additional mathematics, inverse functions do not just exist in a vacuum. They aren't just isolated algebraic puzzles. They are deeply, intrinsically connected to coordinate geometry, graphing, kinematics, and calculus. When you find an algebraic inverse, you are simultaneously geometrically reflecting the original function's graph perfectly across the diagonal line y equals x. If you can reference that graphical connection in your mind to check your work, or if you fundamentally understand how the domain of the original function explicitly and inevitably becomes the range of the inverse function, you are demonstrating real cross-topic mastery. You aren't just an algebra robot churning out numbers, you are a mathematical strategist. You are the jazz musician who understands why the notes work together. Moving into Section 2, the procedural framework. Here, we translate that foundational theory into a highly reliable, standardized methodology that you can use on exam day.
Systematic processing follows this standardized 5-step sequence. Identify, apply, execute your working, verify, and present cleanly. I like to call this the mathematics success blueprint. This framework heavily relies on what Cambridge markers call the method mark strategy. You need to internalize the fact that the process itself secures your points. The final answer is only part of the battle. The examiner's mark scheme is rigidly divided into M marks, which stand for method, and A marks, which stand for accuracy. Let's think about our overworked student Alex. If Alex had just slowed down, followed step 1 to identify the key elements, and written down the initial correct mathematical step for swapping his x and y variables, he would have instantly secured a method mark. Even if his subsequent algebra completely fell apart because he dropped a negative sign in the heat of the moment, that method mark is locked in. By applying these 5 steps, you are forcing your brain to slow down just enough to be methodical and capture every single M mark available, while staying organized enough to beat the ticking clock. You identify the function, apply the inversion rule, execute the algebra, verify it by making sure the domain and range flip correctly, and then present it in that flawless f inverse of x notation.
But before your pen even begins calculating the algebra, you must practically apply professional exam skills by deconstructing the question prompt. I want you to imagine a 60-second timer counting down right now. You flip the page, and a complex, highly intimidating math question is sitting in front of you. The biggest mistake you can make is immediately starting to write. The first 15 seconds of that timer shouldn't be spent doing algebra. They should be spent deconstructing. You need to act like a detective, extracting relevant data. What is the specific command word? Is it find, state, evaluate, or show that? What is the domain given in the bracket next to the function? Is the function actually one-to-one, or is there a trick hidden in there? You extract that data first. Instead of diving straight into manipulating variables and moving terms across the equal sign, you pause. You write down the original function clearly. You note the given domain right next to it. You select your analytical framework, in this case, our Peel method. This intentional, calm extraction phase is exactly what sets up your method marks and separates the average panicking candidate from the exceptional strategic one. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Let's transition to Section 3, executing with precision, and see how this framework actually builds into executing a real mathematical transformation with absolute accuracy.
Let's get into our interactive workshop. This beautifully illustrates the precise transformation required, moving from an exponential function to its inverse using correct notation and clear formatting. Let's do a data scan challenge together. Look at the original function. f of x equals e to the power of 2x. Now let's walk through the exact Peel method for this specific problem to guarantee every mark. First, the point. We explicitly identify and write down f of x equals e to the power of 2x. We state that we are looking for the inverse. Next, we move to the evidence. This is where your precious method marks live. You write your first structural step. Let y equals e to the power of 2x. Now we need to execute the algebra to make x the subject. To get that x out of the exponential power, we have to apply the natural logarithm to both sides of the equation. So you write down ln of y equals 2x. We then isolate x completely by dividing both sides by 2, which leaves us with x equals 1/2 times the natural log of y. Boom, the algebra is done. Method marks secured, but we are not finished. Now for the explanation and link. If we stop here, we are just like Sam, rushing and losing the accuracy marks. We explain our next step by swapping the x and y variables to officially define the inverse relationship. And finally, we link it perfectly back to the required syllabus notation. So our final presented answer on the page isn't y equals 1/2 ln of x. That's a trap. It is strictly and explicitly f inverse of x equals 1/2 ln of x. By laying out this evidence vertically, line by logical line, you leave the examiner absolutely no choice but to award you full marks. You have made their job easy.
Now notice the prominent number 1 on the screen here. I want to drill this into your memory. An inverse only mathematically exists if the original function is strictly 1-to-1. This isn't just trivia. This is a vital piece of context and a massive trap set by examiners that you must always evaluate before doing any algebra. Let's do a quick speed challenge. Imagine scanning a complex parabolic graph in your mind right now. Picture a U-shaped graph for f of x equals x squared across all real numbers. Now, is that function one-to-one? Absolutely not. It totally fails the horizontal line test. That means for any given positive y value, say y equals 4, there are two possible x values that map to it. In this case, positive 2 and negative 2. Because of this ambiguity, it does not have an inverse function at all, unless the domain is strictly restricted by the examiner, for example, to only x values greater than or equal to 0. If you don't evaluate this one-to-one property first, you will fall right into the examiner's trap. You will waste 5 minutes of valuable exam time trying to solve a mathematically unsolvable algebraic equation, all while the clock is relentlessly ticking down. Always check the domain restriction first.
Finally, let's turn to Section 4, Examiner Insights and Pitfalls. This is all about protecting the marks you've worked so hard to earn by exploring the most critical mistakes students make year after year.
I want to present you with the final system. These are the 3 rules that guarantee top marks. Number 1, command word decoding. Number 2, Peel framework application. And number 3, the time management matrix. Why do we need these 3 rules? Because principal examiner reports explicitly and repeatedly warn that students consistently lose marks across 4 major areas. Let's play Find the Flaw. Listen to this flawed sample paragraph from a student. I swapped x and y, and since the original function was a curve, the new one is the inverse. So y is the inverse. Did you spot the flaws? That student just threw away half their marks. First, saying since the original function was a curve is incredibly vague and mathematically meaningless. It completely violates warning number 1 about lacking detail. Curves can easily be many to one, like a sine wave. Second, finishing with so y is the inverse ignores the proper f inverse of x presentation format, violating warning number 2. And when examiners say answers aren't specific to the context, they mean calculating an inverse in a word problem without realizing the real-world scenario, like calculating a time or a physical distance, makes a negative algebraic result physically impossible. You have to reject the negative root, but students forget because they aren't paying attention to the context. To evaluate the absolute quality of your mathematical evidence, you need to identify limitations, spot the assumptions you are making, consider alternative interpretations, and weigh their effect on your final conclusion. This might sound like a science experiment, but it applies perfectly to O66 math. It's all about speed and accuracy under pressure. The biggest limitation of an inverse function is that it is strictly and entirely bound by the original domain. Your analysis on the exam paper must identify the specific boundary values given in the question. You must explicitly recognize the assumption that the range of the original function strictly dictates the domain of your new inverse function. And most importantly, you must clearly state those final domain constraints right alongside your final equation. Top-tier quality analysis means seeing the invisible boundaries and constraints around your algebra and communicating them clearly to the examiner.
So the crucial point here brings us to a major examiner alert directly from the grading reports. Candidates consistently confuse terminology. You must define your terms clearly before deploying them in your working. If a multi-part question asks you to state the domain of the inverse function, do not just write down a random inequality like x is greater than 5 and hope for the best. Define the mathematical relationship to prove you know what you are doing. Write down this exact sentence. The domain of f inverse of x is equal to the range of f of x. Then, go and calculate the range of the original function and present that specific interval as your final answer. This explicitly shows the examiner you understand the deep, interconnected mathematical terminology. It transforms your answer from a hopeful, messy guess into a definitive, authoritative statement that commands full marks.
As we wrap up this explainer, I want to briefly recap our core strategy. You have to be the jazz musician. You have to know the rules. Always decode the command word before your pen touches the paper. Structure your algebraic steps with points, evidence, explanations, and links, and actively deconstruct the domain and range parameters of the question to avoid falling into time-wasting traps. Strategy is utterly useless without execution. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams @Ace the Exams IGCSE to excel in your Cambridge examinations. Subscribe right now to @Ace the Exams IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.